Okay, starting up again. Force problems. So this is basically how you put everything together. Um, Going from kinematics to dynamics. So this is putting pretty much everything in the course to this point together. One thing I just want to point out, you're going to see these little squares. Unfortunately, that's because the program I'm using doesn't actually do the vector symbol, the little half arrow. Um, all the vectors, so displacement, velocity, acceleration, momentum, should have a little half arrow on top of it. We're just going to ignore that for now because there's no really convenient way to do that with the Google Suite. So for you guys submitting things or me doing that for you, we're just going to sort of ignore that for now. But please remember next year, for vectors, you need to put a little half arrow on top of things. And I'm sorry about the squares. Um, Google doesn't do that. So to completely describe the motion of something, there's 5 things you need to know. Displacement, D, initial velocity, V1, final velocity, V2, time, and acceleration. Now, the only force that affects something's motion is the net force, F net. And the cool thing is, we can break down F net into vertical and horizontal and solve them separately. So one of the nice things with components and why I like using components for vectors is you actually can solve horizontal forces and vertical forces completely separately. And that way you're only ever doing a one-dimensional vector question. You're not having to do all sorts of really crazy triangles. So a force problem is putting everything together. So the nice thing about this is there's only really 2 problems I can ask you. One is going from the net force. If I give you forces, you can use Newton's second to find acceleration, then use that acceleration to figure out the kinematics, what's happening. Or we can go backwards. I can give you the kinematics, how I want an object to move, and you can work from the kinematics, solve for acceleration, put that acceleration to net force, and then take that net force and figure out all the different forces you need. So this is literally the 2 steps. So first off, figure out which one it is. Are we using forces to find a particular motion? Or did I give you a motion I want, and I want you to find a force that's necessary? So if you're using forces to find motion, free body diagram, find the net force. Usually it'll only be a horizontal net force that we're worried about. The vertical one will typically cancel out. Use F equals ma to find the acceleration. Use the acceleration, plug that into the kinematics equations, find whatever motion I'm asking you for. Or if I give you a specific motion, use the kinematics equations. You're going to solve for acceleration. Use F equals ma to find the net force. Then use a free body diagram and the net force calculations to basically figure out the missing force. So it's the same question, just forward or backward, basically. The kinematics equations, again, sorry about the squares, are these ones, except you're not going to use the one with no acceleration because you're always going to be trying to find an acceleration. So based on what kinematics I give you, I'm going to always give you 3 and ask you to find the acceleration. That's basically the trick. So for all these equations, you either have the acceleration you found from F equals ma, or you're solving for the acceleration to plug it into F equals ma. F equals ma, Newton's second law, is the link between kinematics and dynamics. So, for example, if you've got a car traveling at a velocity of 100 kilometers an hour forward on dry asphalt, you want to slam on the brakes and stop the car? Do you want to know how fast is the car going to stop before you've actually hit the brakes? This is usually something kind of important to know. We want to know what the stopping distance is. So in this case, I've given you forces. We're trying to find a distance. So we're trying to find kinematics. So we're going to use forces first and then try to find something for kinematics. So we start off, we draw the free body diagram. If you're slamming on the brakes, there's only one force, friction. Hopefully you don't have your foot still on the gas, so there shouldn't be an applied force. Hopefully also the normal and force of gravity are going to cancel out. So when we write out our net force equation, we know gravity and the normal force are going to cancel out because your car isn't sinking or rising. All your acceleration is going to be horizontally because that's just what happens when you hit the brakes in a car. So the net force is the force of friction. We can find the force of friction from mu times Fn. In this case, Fn will be Fg because it's not on a slant. There's no other vertical forces to cancel. We find the force of friction. That's our net force. We plug that into acceleration is F net over m. Find what our acceleration of the car is. Then we plug that acceleration in with the kinematics that we know. We know initial velocity. By the way, if it ever seems that there isn't enough information, look for something in the question that either says that V1 or V2 is 0. So in this case, the car stops. That means V2 is 0. So acceleration, V1, V2. Don't forget to convert to meters per second. We're solving for distance. What don't we have? Don't care about time, so we're going to use this equation. D is V2 squared minus V1 squared over 2a. Plug in the numbers, get an answer, 38 meters. So that's it. If you're going 100 kilometers an hour and your brakes work perfectly, please ignore the dumb dog barking in the background. You can't stop in less than 38 meters. It's not physically possible. So, what if you're going down a hill on wet asphalt? So let's do the same question, and let's try to find what's happening if you're on wet asphalt. Now, first off, we got to find the forces. In this case, there's going to be a vertical and a horizontal force because we're going down a hill. So let's rotate the world to make it a little easier. So we only need to break down one thing, the force of gravity. And let's solve the forces separately because the net force vertically and horizontally don't really affect each other. The only thing that's going to happen is we need to know the vertical force. The only reason we even need to know it is to find that normal force because we can't find the force of friction without it. So vertically, there are two forces. There's a normal force and there's the y part of the force of gravity. So we know the net force has to be 0 because the car is not sinking into the road or flying off the road, hopefully. So the net force vertically is normal and the y component. The normal is what we're trying to find. The net force is 0. The y component is just the force of gravity, mg, times the cosine of the angle because it's the adjacent side. Plug in the numbers, you can find the normal force. We then look horizontally. Horizontally, there are only two forces. Force of friction slowing you down, but there's also this x component of the force of gravity that's pulling you forward down the hill. So we write those out, we plug it in. The F is mg sine theta because it's the opposite, plus mu times Fn, which we found ahead. By the way, remember, force of friction is always backwards, so just ignore the direction for the normal force. Plug in the numbers. The coefficient is 0.55 if you're on wet asphalt, times Fn. Find a net force. Take that net force, plug it into F equals ma. Find your acceleration. Then we're solving for distance. We know V1, we know V2 is 0, we know the A now. We want to find D, plug it in the equation, and you get 110 meters. So because friction is less, and because you're going down a hill, so there's the x component, you're going to slide a little farther. All right? So that's a good example of how we can use a force. And this is, by the way, is one of the more complex questions I could ask you. How do we find a force to solve for distance? Last question. Pushing on a snow shovel. This is another one where we can get a weird vertical force because if you'll notice now, there are three forces in our vertical component. Fn won't be Fg because Fn, Fg, and the y component of me pushing down have to cancel out. So this is also a question where I want to know a force. So I want to know the coefficient of friction. I'm basically saying what's the force of friction and asking you one more step. So We pushed 20 kilograms of snow with a shovel with a force of 350 newtons at a 75-degree angle, giving the snow an acceleration of 1.2 meters per second. So we've already done the kinematics to give you the acceleration. I've just skipped a step. So we take the acceleration, use F equals ma, find the net force we need to give the snow that acceleration. Then we'll look at the vertical forces. In this case, there are three. We know they're going to equal 0, but there are three forces. There's the force of gravity down. There's the y component, which is going to be down because I'm pushing down on the snow shovel, and the normal force, which is going to be up. So plug it in, mg. Fy is my angle. So 75 degrees to the horizontal. That means this angle is 75 as well by Z theorem. Opposite, so it's going to be sine. We can find the net force. And then use that, we know that's 0. We can find the normal force because it's going to be whatever cancels out those other. It's going to have to cancel out this force and that force. That's why you're adding them together. Then we take the normal force. We look at the x component. Well, in the x, there's only two things. There's me pushing forward on the shovel, and there's friction pushing back on the snow. So Fx and Ff. Fx is just F, my applied force, times the cosine because it's adjacent. The force of friction is mu Fn. I know what Fn is. You plug in the numbers. The only thing you don't know is the coefficient. You can then solve for it as 0.13. So as I said, the whole trick to this is A, break the forces up into vertical and horizontal, and B, identify which am I doing first. Am I trying to find a motion or am I trying to find a force? That basically gives you the way to do it. All right, good luck.